Google's DeepMind just unveiled something that might be the closest thing we've seen yet to the AI matrix. It's called Genie 3, and it's not just a leap, it's a portal into a whole new reality. This thing can literally take your words and build an interactive, consistent, dynamic world. In real time. Yeah, you type it, Genie 3 makes it real. Like a game engine powered by your thoughts. But here's where things get even crazier. This isn't just for fun and games. Genie 3 is being positioned as a next-gen training ground for humanoid robots. We're talking about fully embodied agents learning in high-fidelity, physics-consistent, evolving simulations. This could be the system that finally gives robots a true childhood to grow up in, learn safely, and become world-ready faster than ever before. And just when you think we're done, no, the plot thickens. Because once we dive through the Genie rabbit hole, we're going to shift over to Astrobot, who just announced their new AI robot development suite, a complete vision language action loop that lets researchers iterate and deploy robotic intelligence in the real world faster than ever. We're talking plug-and-play AI training with real hardware, natural teleoperation, and validation all baked into one sleek platform. So welcome back, guys. Alfie here with these two major updates. If you've ever wondered how we go from today's humanoid prototypes to fully functioning real-world AI assistants, buckle in. This episode's gonna connect those dots, and it all starts with Genie 3. Let's go. So, what exactly is Google Genie 3, and why are people calling it the Matrix? Well, it's the third iteration of Google DeepMind's Genie world model. And while the earlier versions were impressive, Genie 3 crosses a line into full interactive video generation, driven purely by text prompts, mouse movement, or even controller inputs. Imagine typing a futuristic city made of glass with flying robots and moving walkways, and immediately getting a high-quality animated world you can move through, influence, and interact with. No level design, no pre-programmed characters, just the AI filling in every detail procedurally from scratch and remembering what it built. That memory part is key. Genie 3 doesn't just create visual content, it maintains visual consistency for over a full minute. That means if you turn around, the house you passed a while ago is still there. Objects don't just disappear. Worlds persist, like they would in a video game engine, except this isn't scripted. It's imagined by the AI, and here's where your jaw might hit the floor. Genie 3 isn't using traditional graphics pipelines. It's not Unity or Unreal. Instead, it's using a causal, token-based world model. Think of it like GPT for physics-based video. It treats every frame, every object, every movement as a prediction problem, stringing them together with learned consistency. This is how it can generate rich, open-ended environments that still obey the laws of physics. We're talking about a system that doesn't just make stuff look cool, it makes it function believably. Okay, but what does this mean for robots? Everything. Because one of the biggest bottlenecks in training humanoid robots isn't the hardware, it's the learning environment. Teaching a robot to walk, navigate, use tools, or react to unpredictable changes in real time requires tens of thousands of hours of experience. But letting that happen in the real world is dangerous, expensive, and slow. That's why researchers use simulations. But even those have limits. Most current robot training simulators are static, brittle, or require tons of manual design. You get clean, lab-like scenarios, not messy, chaotic, real-world challenges. Enter Genie 3. This could be the training sandbox robots have been waiting for. Because Genie 3 lets you dynamically generate any scenario. Want your humanoid to practice in a bustling kitchen with slippery floors? Boom! Need it to learn to navigate an unfamiliar warehouse with low lighting and obstacles? Done. How about learning to work alongside humans in a hospital setting with unpredictable noise, movement, and emergencies? Genie's got it. What we're looking at here is the foundation of sim-to-real transfer done right. Because Genie's simulations don't just look real, they operate with temporal coherence and physics-informed dynamics. And that's exactly the kind of learning environment where embodied AI, meaning robots with a physical presence, can develop high-level behavior without breaking things in the real world first. Let's talk about visual memory. Because this is where Genie 3 destroys everything else in the category. Most video generation models can give you a few seconds of consistent footage before things go off the rails. Genie 3 gives you over 60 seconds of coherent world building, with entities that remember where they are and what they were doing. That's the equivalent of giving AI a working short-term memory, and it's absolutely essential for robots. Why? Because if you want an agent to plan long-horizon tasks, like cleaning a room, assembling a machine, or assisting in a complex medical procedure, it needs to remember context across time. Genie's ability to generate and maintain consistent scenes isn't just eye candy. It's a training revolution. It means an agent can practice multi-step tasks without having the world shift around it arbitrarily. And that unlocks smarter, more strategic learning. Now this might sound familiar, because this is the holy grail of world modeling. And DeepMind has been heading in this direction for a while. But Genie 3 is different because it's interactive. This isn't a passive video generator. You can give it real-time control input, keyboard, mouse, even game controllers, and it responds. That's a game changer, literally. We're talking about a general-purpose simulator that doesn't need to be built level by level. It builds itself as you go. That unlocks new possibilities not just for robots, but for AI agents, virtual assistants, gaming NPCs, training environments, and beyond. And here's a big one. Genie 3 is modality agnostic. It's not just taking text and outputting video. It's integrating input from vision, language, action, and planning, and using that to maintain control over evolving environments. In simpler terms, this thing can understand, react to, and build around your behavior. It's like ChatGPT crossed with Minecraft, but instead of blocks, you're crafting entire simulated universes. Now let's be real, Genie 3 is still in research. DeepMind hasn't released it to the public yet, and for good reason. The implications are massive. This kind of technology could be used to revolutionize education, training, robotics, gaming, remote collaboration, and even psychological testing environments. But it also raises big questions about what's real. If Genie 3's worlds become indistinguishable from reality, and robots start learning in them, we're entering a future where virtual and physical lines blur, where simulated experiences carry weight, where your AI assistant could have lived 1,000 lives before ever entering your kitchen. We're talking about an AI matrix, not one to trap us, but one we create to train the minds of our future machines. And that brings us to the next frontier. While Genie 3 is building the simulation, Astrobot is bridging the gap to the real world. They just announced something called the Astrobot Suite, and it's basically a one-stop shop for AI robot development. Think of it as a closed-loop ecosystem that covers everything from perception to action to validation. Here's the idea. AI researchers need to constantly iterate between models, hardware, and real-world testing. But that process is slow, fragmented, and error-prone. The Astrobot Suite solves that by combining a high-performance robot platform, a full teleoperation pipeline, vision language action modeling tools, real-world testing, and feedback loops. This means researchers can design a model, test it in simulation, run it on a real robot, validate its performance, collect more data, retrain, and repeat the cycle without leaving the suite. It's rapid iteration, optimized. And this matters because modern robot intelligence doesn't come from pre-programmed behavior anymore. It comes from learning, reinforcement, trial and error, multimodal data, and massive iteration. The Astrobot Suite makes that scalable. But what really sets Astrobot apart is their focus on teleoperation. You can literally control the robot remotely, capture human demonstrations in high fidelity, and use that to train or fine-tune your AI models. This is huge for vision language action models, the kind of AI that understands what it sees, reads, and hears, and uses that to act in the world. By turning human intuition into training data, and by letting that loop run faster than ever, Astrobot isn't just building smarter robots, they're helping the entire field move faster. And let's not forget, Astrobot already stunned us earlier this year with Astrobot S1, a human-sized robot with smooth motion, lightweight design, and dynamic AI control. The new development suite plugs right into that, meaning everything we saw in the lab can now be iterated on in weeks, not years. So let's tie this all together. On one side, we've got Google's Genie 3, building the Matrix, a fully interactive, physics-aware, memory-capable world model for training robots before they ever take a real step. On the other side, we've got Astrobot, giving us the hardware, control interfaces, and development tools to bring those AI minds into the real world faster than ever. This is the future of AI robotics, a seamless end-to-end intelligence pipeline from simulated experience to physical action. It's not just about building smarter robots. It's about building them faster, safer, and with a better understanding of our world. The lines between training and deployment, between virtual and physical, between imagination and embodiment, they're all blurring. And just when you thought that was the most shocking thing AI has pulled off recently, think again. Because what Figure 2 just did inside a regular home might be even more unbelievable. It did laundry. Yes, laundry. And not in a lab, not in a simulation, but in the founder Brett Adcock's own house. This single act has shocked the robotics world and raised the bar for what humanoid robots are capable of in real-world environments. The footage shows Figure 02 autonomously squatting, balancing, reaching, and delicately loading clothes into a washing machine. The movement wasn't robotic in the old-school sense. It was human-like, smooth, and natural. And this wasn't just about folding shirts. It was about understanding space, executing delicate motion, and adapting to a real home environment that was never designed for robots. It's not an exaggeration to say Figure 02 just crossed a massive line, and the implications are massive. Let's break it down. This robot isn't just walking around and waving for the camera. It's performing a real, complex household task without any step-by-step human guidance. This is autonomy in action, where perception, manipulation, and planning all come together. Figure isn't just aiming to make a humanoid that walks. They're going for full general-purpose utility, and this laundry demo proves they're closer than anyone expected. Now here's the kicker. This was powered by Helix, Figure's in-house neural network architecture designed to drive humanoid behavior from vision to motion. That means the robot didn't follow a scripted set of motions. It saw the environment through cameras, understood the scene, and decided what to do, just like a human would. The fact that it could recognize clothing, align itself, crouch without toppling over, open a machine, and load garments, all in a normal household setting, is huge. This was in Brett Adcock's home, not a polished testing facility, not a staged room built for robots, a normal home. And you can feel that authenticity in the video. You're watching a machine move like it belongs there. It doesn't fumble around like early lab demos. It squats, reaches, and balances like it understands the room. That's a level of contextual awareness we've barely seen outside of research papers or isolated tests. Figure 02 isn't doing a party trick. It's handling a daily human task like it was born to do it. But this isn't just about one video. It's a statement. Figure is aiming to produce 100,000 units of its humanoid robots within the next 4 years. That's not a hypothetical stretch goal. It's a declared target. And with each new video, the road to that goal seems more real. Trials are already happening at BMW and a major unnamed tech company. We're watching Figure go from prototype to production, from one-off tests to industry-wide deployment. Let's talk about why this matters. Robots doing laundry sounds like a novelty until you realize the complexity involved. Laundry involves soft objects, clothes that don't have a fixed shape. It requires fine control, visual classification, and mechanical flexibility. You have to recognize shirts versus towels. You need to apply the right amount of force to pick up a bundle without dropping it or tearing it. You must avoid bumping into walls, slipping while squatting, or misaligning the drum of the washer. And Figure 2 just did all of that. And remember, this is only version 2. Figure F02 is already showing high-level embodied intelligence, and version F03 is right around the corner. Brett Adcock has confirmed it's coming soon, and if F02 can already handle laundry like a pro, you can only imagine what F03 will bring to the table. Will it cook? Will it clean entire homes? Will it operate in hospitals, warehouses, or retail stores? We're approaching a threshold where those questions aren't futuristic, they're logistical. Figure's vision has always been crystal clear. Build a general-purpose humanoid that can work safely alongside humans in the real world. Not just in factories, not just behind closed doors, in homes, offices, shops, schools, you name it. And the laundry video makes it harder and harder to argue that this isn't possible. Because now it's happening. What makes this even more important is how it's being done. Figure's robots aren't being manually programmed step by step. They're learning from data. They're powered by large-scale neural networks that combine perception, language, and motion. Helix allows the robot to see a scene, understand what's going on, plan a course of action, and execute it, all with fluid motor control. It's basically an embodied AI agent, but in humanoid form. So when we say Figure 02 crossed a line, it's not just about doing laundry. It's about stepping into a new phase of robotic capability, where the robot is no longer waiting for perfect conditions. It's no longer confined to labs or controlled factories. It's entering our world and learning to operate within it. There's also something psychological here. Watching a robot do laundry in a normal house hits differently than seeing one stacking boxes in a factory. This is intimate. This is domestic. It makes the idea of robots in homes not just believable, but inevitable. You don't need imagination anymore, just look at the video. And once you see it, your mind starts racing. If it can do laundry, what about dishes, vacuuming, making beds, folding clothes, taking out the trash? These are not wild predictions anymore. They're next in line. Because once you build a platform that can navigate tight indoor spaces, manipulate unpredictable objects, and do it with a human-like body, you've unlocked a lot more than one chore. Now zoom out for a moment. The broader humanoid race is heating up fast. Tesla Optimus is training in factories. Agility's Digit is working in warehouses. And now Figure is casually doing chores in a founder's house. The bar just keeps rising. And what sets Figure apart is how fast they're iterating. F01 was announced in 2023. F02 was shown in action within a year, and now it's autonomously operating in a real domestic space. If F03 arrives soon with another jump in capabilities, Figure might just leapfrog the competition. And the company isn't staying quiet. Brett Adcock has been vocal, sharing frequent updates, raw footage, and behind-the-scenes progress. It's not smoke and mirrors. It's real engineering. And that transparency builds trust. We're not seeing CGI concepts or rendered ideas. We're seeing a physical robot crouch, balance, and handle real-world messiness. No strings, no tricks, just progress. That's what makes this moment so different from all the previous humanoid hype cycles. We're no longer talking about someday. We're watching it happen. And the economics are starting to make sense too. Figure's stated goal is to mass-produce these humanoids and get the price down to a point where real businesses, and eventually households, can afford them. It's not just about the tech anymore. It's about scaling that tech. 100,000 units in 4 years isn't a moonshot. It's an industrial roadmap. And remember, Figure isn't doing this alone. They're backed by serious investors. They've secured partnerships with BMW and a leading tech giant that, while unnamed, is almost certainly one of the big players like Google, Amazon, or Apple. These aren't experiments. They're deployments. Real-world trials in real facilities with real business goals. So what does this all mean for us? It means the humanoid robot you imagined from sci-fi isn't fiction anymore. It's folding your clothes. It's walking around your kitchen. It's getting ready to move into real homes, real jobs, and real daily life. And when you consider the pace, how much Figure has accomplished in just 2 years, it's fair to ask, how long before one of these robots is doing your laundry, or unloading your groceries, or tidying up your living room? That's where this is going, and Figure is making sure we get there fast. So what's next? We're expecting to hear about Figure F03 very soon. It'll likely include improvements in mobility, strength, efficiency, and possibly new sensors or smarter vision systems. And if the leap from F01 to FE02 is any indication, F03 could push boundaries even further, maybe even outside of human-scale tasks into truly superhuman efficiency. But even if all Figure did was perfect the home use case, Cleaning, organizing, cooking, helping the elderly, it would be a game changer. The economic and societal impact would be massive. Millions of households could offload hours of repetitive labor. Elderly people could stay in their homes longer. People with disabilities could gain new independence. The use cases are endless.